Welcome to Brain Vision.
In this question, there are three forces acting on the car: the weight force, the normal force, and the frictional forces. And the initial velocity of the car is 16.1 meters per second. Given that information, we have to calculate what is the velocity of the car after 1.3 seconds given the frictional force. So we have to begin this question by calculating the acceleration of the car. And how can we calculate the acceleration given some forces? We can use Newton's second law. Newton's second law tells us that the net force that acts on the car is equals to the mass of the car times its acceleration. We will apply Newton's second law on the horizontal axis, which I will choose to be pointing to the right. So everything that is pointing to the right will be positive, and everything that is pointing to the left will be negative as a consequence. Then, the net force on that horizontal axis is given by the frictional force only. So, minus the frictional force is equals to the mass of the car times the acceleration of the car. But the frictional force in the situation where the object is already moving is given by the kinetic frictional coefficient times the normal force. And this is equals to the mass of the car times its acceleration. It happens that in this situation, the normal force is exactly counterbalanced by the weight force. And then we have that the normal force is equals to the weight force. So that here we get minus the frictional coefficient times the weight force is equals to the mass of the car times the acceleration of the car. And the weight force is given by the mass of the car times the acceleration of gravity. So we get this equation. We have mass on the left side of the equation and on the right side of the equation, and it's multiplying both sides. So we can simplify it out to get minus mu k times the acceleration of gravity is equals to the acceleration of the car. The acceleration of gravity near the surface of the Earth is equals to 9.8 meters per second squared. Then, plugging in the values that were given in the problem, we get minus 0.72 times 9.8 is the acceleration of the car. And this results in an acceleration of minus 7.056 meters per second squared. Now we can calculate what is the velocity of that car given its initial velocity and its acceleration. We have that the velocity of the car after an interval of time delta t is equals to the initial velocity of that car plus the acceleration of the car times that time interval. Then, plugging in the values that were given by the problem, we get that the velocity of the car after this 1.3 seconds is equals to the initial velocity of the car, which is 16.1 meters per second, minus 7.056, which is the acceleration, times the interval of time of 1.3 seconds. This minus sign is because the acceleration is negative. Then we get that the velocity after 1.3 seconds is approximately 6.9 meters per second, and this is the final answer of the problem.